All right, so let's take a look at this. Now, these are typical problems you'll get in calculus too, because there's not an answer yet, because you've got a variable that goes through the whole entire problem. But we also have a lot of domain restrictions here. So be careful on the domain restrictions. Radicals give you a domain restrictions and fractions, and radicals under fractions. Those are your 3 domain restrictions. So make sure you take that into account. All of these were in quadrant 1 because all of these were positives. So they were all sitting in quadrant 1. And in quadrant 1, remember if you're doing sines, boys, yes? So if you're doing sines and cosines, you're between 0 and 1. Tangents, a little bit more than 1. But sines and cosines are always between 0 and 1. So let's take a look at what you have here. So you've labeled your sides, you found your missing side, and then you go back at the end and find your domain restriction. Good?
So
yes?
You only plug in, oh, okay, I see it. I got it.
Yes, sometimes it looks pretty bad. You cannot take the square root of this guy because this actually comes 1 minus 2x and 1 plus 2x. It's your difference of perfect squares. You can't take the square root of this. This has 2 terms. You can take the square root of a single term, but not 2 terms.
So for number 1 with the domain, you don't take the missing value to find the domain restriction.
You use whatever, like what your issue is. It's a fraction. I can't have a 0 in the denominator. So this guy has a fraction with a radical. So my radical cannot be negative or 0. So I've set this equal to greater than.
Wait, that's not a fraction.
Okay, this is not a fraction. So set this equal to greater. I saw the 1. Sorry. So set this equal to greater than 0. But where is it? Wait, where is it? It's over here. Here it is. Set it equal to greater than or equal to 0. And then find your roots. Now, be careful on your quadratics. It's not just these 2 values. Greater than or equal to, because this is not in the denominator. My 1 goes to this guy. So what you want to take a look at is once you find your critical values, remember how we put it in your calculator, we tested it? This is a parabola. This is going to open down. So your parabola is going like this. It's got to be positives in here. And you can't have negatives in your under your radicals. So it's got to be from here to here. Now the problem with this is from negative 1/2 to positive 1/2, it can't be 1/2 because we're in quadrant 1. It can't be negative 1/2 because we're in quadrant 1. So this has to come down to a 0. You got to apply it to the situation. Okay? Which makes it just a little bit tougher.
So this isn't on the test, right?
Yeah.
It is on the test.
Yeah.
Of course.
But it's no different than what you've been doing. It just looks a little worse because you're not coming out with a 1/3 or a radical 3/2. You're coming out with something with x in it, with a variable, because we have a variable to use.
Well,
Because normally if you find the sign of something, you find the sign and the sign is radical 3/2. You have no domain restrictions. You have numbers in here. You have values in here.
yeah.
Here you don't have values. You have x's.
So
Your variable.
my question is, once you found the 1/2 and negative 1/2, why did you do 2x is greater than or equal to 0?
2 and what?
I don't know. I don't know where that came from.
So wouldn't the domain be negative 1/2?
Oh, because this has to be greater than 0. This piece right here, it can't be less than 1. That piece can't be less than 1 because this is 1 right here. You don't have to do this. You could just like this makes why the 0 is here. Because this piece right here cannot be greater than 1. And it cannot be negative. So I've got to be greater than or equal to 0. And it's obviously this is going to be my other endpoint of this. So this is where the 0 comes in.
Well, isn't 1/2 squared 1/4, and then 4 times 1/4 would be 4, or 1.
1.
And then 1 minus 1 is 0.
4 times 1/2, 1 minus 1 is 0. You can't have a 0. And,
but it's not in the denominator. It's just a radical.
right, so that's why there's an equal sign. You can have that. you can have a 0.
Yeah.
Right. This is why there's an equal sign for 1/2.
So, but I'm saying, why can't you have the negative 1/2 in the domain?
Because the negative 1/2, you're only in quadrant 1.
Oh, okay.
So
All right.
this part takes care of, this part right here takes care of quadrant 1.
I got it. I was just
But
plugging
you don't
it
have to do this if you eyeball this first and say, oh, I can't have a negative, I'm in quadrant. All of these came in quadrant 1. So they're all going to have that issue. If you want to, absolutely do this piece here, but you don't have to. You can just say, can't have a negative, I'm in quadrant 1.
All right.
Right?
I wasn't looking at the quadrants.
Mm-hmm.
I just
It's a
plugged
little tight in here. I'm sorry, I wrote a little bit tight in there.
I just plugged it back in and it ended up being 0.
And you can have a 0 in there.
Yeah, it just, yeah.
Or a sine or a cosine. Okay, the next guy, we're still in quadrant 1. Everybody's positive in 1. And this one, did it have a domain restriction? It had a radical. And again, find your critical values. And your parabola, again, is opening down. So your values are good between -1 and +1. But again, this can't be negative. It's got to be greater than 0. So you're going to have to start at the 0. So from 0 to 1. And it kind of makes sense because doesn't your value have to be between 0 and 1 if your radius or your hypotenuse is 1?
Yeah.
Right? It makes sense to you. We're on a unit circle according to this. If this is a unit circle where my radius is 1, these guys have to be less than 1. And because I'm in quadrant 1, they cannot be 0. Right? So it makes sense if you think about it. The next guy, cosine. You have to find the tangent of an angle whose cosine is x over 3. Now you're not on a unit circle. So your x value can be greater than 1. It can't be greater than what? 3. So when we find this, again, we're from -3 to +3, but we can't use the negatives because we're in quadrant 1. So we're from 0 to 3. And doesn't that make sense that that value has to be less than the hypotenuse or the radius of a circle? Right? These make sense if you think about it. If you look at it as all x's, it's like, where the heck did this come from? But if you kind of make sense out of it, your right triangle says your hypotenuse is the greatest length. It does make sense. And if you're in quadrant 1, you can't be negative. If you're in another quadrant, yes, you can. But, well, tangent would be, according to this one, if it were you looking for the tangent and you were looking for x, and your cosine was, well, if it was negative, it would be in the other direction. But we're strictly in quadrant 1, so we were okay with that. This last one, okay, this last guy, again, quadrant 1. Set this up, and be careful of this guy. You have 2 domains to worry about. However, this one, does this guy have a restriction for the radical? Will it ever be negative? No, so you didn't have to worry about that. You just had to worry about your denominator. You don't care if that's a 0. You can have a 0 there, and you're never going to get a 0 anyway. But you can have a 0 for that guy. So all you have to worry about is your denominator. This is very important, the restrictions. Okay. Are we okay with this? All right, so let's take a look at it, and you tell me, this is your review. So you tell me where your questions are. You have to be able to graph this, full cycles, no calcs.
Did you go to 4 pi?
Am I at 4 pi? Yes.
Oh, okay.
I only went to 4 pi because since this is a half, if you did this, that's okay too. I get a full cycle. But technically, my first full cycle is from 0 to 4 pi.
I just wanted to make sure. If I only went to 2 pi on the test, would that be okay?
As long as you went to -2 pi, because you didn't get a full cycle then.
Like -2 pi to 2 pi.
Yeah, that's fine. And I'll probably tell you where to go on the test.
Oh.
Unless it's a shift and you have to find the cycle. If it's a shift, a phase shift, then you have to find your cycle.
Is she just telling you from 5 over 2 to 9 over 2, just like for the full cycle?
Wait, say that again.
For the full cycle, is it 5/2, 7/2, 7?
No,
Well,
this is your range. This is what's switched over here. The only difference from here to here is this. This wasn't here. Technically, if you want, you can just put it back over here. The only thing that this did, see it's the exact same curve, it just shifted it up 3. So this is your new range. What did this one have to do? Amplitude. So right away my range went from -1/2 to +1/2. Then, in this guy, we picked everybody up 3. So if you take -1/2 and +1/2, and you add 3, you'll get 5/2, 7/2. Okay. But the rest of it stayed the same. Make sure you're able to tell me by using your transformations. I have a reflection in the x-axis, I have a vertical shift up 3, and when my frequency is 1/2, if my frequency is 1/2, what transformation is that?
Horizontal stretch.
It's a horizontal stretch by what?
To a factor 2.
Good. Because what happened to the period?
It doubles.
It doubled. The period went from 2 pi to 4 pi. That's where your factor comes in.
So you do want us to state the transformations when we're doing these, correct?
Well, whenever I give you like a problem, I'll say state the transformation.
Alright.
You'll know when in this one, I don't remember what your direction said because I took it out of your book.
Just said
Full
full cycle.
Okay. I took it out of the book, so I had to make it into a worksheet, so I forgot to say the rest.
Oh, sorry. When it's a vertical stretch or shrink, like the amplitude changes,
Yes.
but it would be like the same. So for the first one, it would just be vertical stretch by factor.
Vertical shrink.
Yeah, sorry. Vertical shrink by factor of 1/2.
1/2. That stays the same, right? Because think of it this way. It was 1. It went to 1/2. So you cut it down. You shrunk it down.
So for the amplitude, you keep it the same, but for horizontal, you reciprocate it.
Right, because doesn't it make sense that way? If you're stretching this out, what did you do to the period? You stretched that out too.
Okay.
Yeah.
Just make
What is your amplitude on this?
1/2.
What about the negative?
It does not apply.
Good. It's always absolute value. The negative is a reflection. It's not the amplitude part. Good. So can we all do this? This is okay? So one full cycle, guys, is going from here to here. If you gave me from -2 pi to +2 pi, I would take that. But I got to get a full cycle out there. Technically, instead of doing it that way, I would really prefer you set this equal to, normally you go from 0 to 2 pi. Take whatever this is, set this equal to 0, and set this equal to 2 pi. So you're going to go from 0 to 4 pi. If you gave me the negative on this,
So like on the test, you want us to just do it from 0 to 4 pi? Or...
I would actually take the negative. It should be from 0 to 2 pi. But if you gave me the -2 pi to +2 pi, that one I probably would give it to you. Okay?
But will you tell us like the?
Well, I'll say you need to get a full cycle. Normally, I'll give you a full cycle on phase shift, and then you have to give it to me from the right start.
Will you say like from 0 to 2 pi? Like will you tell
Well,
us?
all of your graphs go automatically from 0 to 2 pi, because that's where the unit circle is.
Yeah, but I mean like.
But I can't tell you where your full cycle is,
Alright, I was just
right?
Yeah.
I can't.
Because then you'll know what to do. If it's a 1/2 or a 2, you'll know what to do with it. Most of the time, it'll be when you have a phase shift, when you have an angle minus a phase shift. Oh gosh. But if you have a phase, well, when you have a phase shift, you're going to have to start this at pi over 4, and it's going to go greater than 2 pi, right? 2 pi plus pi over 4 gives you what? 5 pi over 4? So you're going to have to tell me pi over 4, this is your cycle. This is what I'm looking for. Most of the time it's obvious in your phase shift. But the rest of your cycles aren't so bad. Okay, this guy, what does the 4 do? Frequency. So how many complete cycles in 2 pi am I going to get? 4. I'm going to get complete cycles in 2 pi. Now, this is a horrible graph, but it'll give you 1 complete cycle. But if you go like this, watch. If you have to get 4, and these are your tick marks. This is your 90, your 180, your 2 pi, your 1 pi, your 2 pi. If you go like this, watch. Make your life really easy. If you need to fit 4 of them in 2 pi, you already have 4 tick marks. What's your period? What's 360 divided by 4? 90. 2 pi divided by 4. Pi over 2. Every 90, you're going to give me 1. And how many quadrants do you have to go through? 4. So mark this off into 4s and start like this. So this is the -3, the 0, the +3, the 0, the -3. Obviously, give yourself a little bit more room. Mark this off into 4s and do it again. Don't do your whole thing in terms of 30 degrees, because that's going to throw you all off. Just make the tick marks that fit your graph. Yes.
Can we just backtrack to the intercept? Do we have to do it, or?
Did I ask you for the intercepts?
No.
Okay, sometimes, remember, we do the, because we're doing around your quadrants, we do the zeros, the mins, and the maxes. So if I ask you for the intercepts, they're at your mins and your maxes and your zeros. You can take that right off your graph, right? Well, that's how you have to graph that's how you're gonna have to graph it. No, yeah, but look, isn't this how you graph it? There's a min, there's a 0, there's a max, there's a 0. Aren't you graphing it off your mins and your max and your zeros? Because you're graphing your cycle of cosine. You're graphing that cycle. So wherever they land, there's your max, there's your min, there's your 0. That's what you're graphing.
Are we finding annual intercepts?
No, just where you had your mins and your maxes and your zeros. The intercept was just at your x-axis. Because that's the cycle you have to graph. All around your quadrants. That's your zeros, your mins, and your maxes. But that's no different than this. Here I am at the 0, -3. Here I am at the, we'll cut this in half. If this is pi over 2, cut it in half. What is it? Pi over 4, then half of pi over 4, pi over 8, pi over 8. Do it that way. Just label everybody by pi over 8 and just count. I wouldn't make my tick marks until I go figure out where my cycle is. Don't make your tick marks standard every 90, every 30, because that'll be horrible. If you think about it in terms of degrees, what's 90 divided by 4? It's not a nice number. It's like 22.5, right? So do I want to have to figure out where my 30 is and my 22.5, and then I have to add another 22.5 and say, where's my 45 compared to my 30? I'm just gonna run that whole tick mark off. If this is from 0, make a big space. If this is 90, cut it in half, cut it in half. So half of this is pi over 4, half of this is pi over 8. Everybody's going pi over 8. 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8. Just count that way. But don't pre-do yours every 30. It'll be very difficult.
I usually pre-do them every 90.
And start with your 90s. Start with your 90s, because that's your unit circle, 90s. Yep. So always start with your 90s, and then this way you can kind of judge where are you. The only one that's probably you're going to do by 30s is the cycle of 3, because it's every 120. And that gives you, always take your period and divide it by 4. That's your quadrants. That goes by 30s.
We just had to find the equation
The 4?
for 3 and 4.
3 and 4. And it looks
Going
like
by 30, you just go by 30, 30, power 2, 30, right?
Wait, I'm sorry, say that again.
Oh.
I wasn't listening to what you said. I didn't know you were talking to me. Every time you guys are always talking out there, I have no idea what you were asking me.
So you said when it says cycle of 30 degrees, so when you graph it, it would be like it would start from 0 and then it would be 30 degrees, and then pi over 2 and then 30 again, and then pi.
If you're gonna do this, watch. This tells you 3 cycles, right? So here's your 90, your 180, your 270, your 360. I gotta get 3 of these. So think in terms of degrees. That's every 120, every 30. So watch, just go like this. Make your tick marks every 30. Don't count them though. So you're here. So your sign says 0, 1, 0, -1, 0. You just did 1. And you're stopped at 120. Now if you need to count them, this is pi over 6. Just go by, now watch. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Just count by pi over 6. And then all you have to do is reduce it. But don't try to convert to pi over 6. Oh, then the next one is pi over 3. Oh, then the next one is pi over 2. Don't convert those until the end. Just keep counting them. If this guy is 30 degrees, pi over 6, this is 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. They'll just reduce at the end. But what you need to get is a way to count them without trying to convert it in your head all the way. Because it's very difficult to say, oh, well, the next one is 60, oh, that's pi over 3. Oh, the next one is 90, oh, that's pi. Just keep counting them in the same increment all the way through. It just works so much better if you just work off your 90s and then separate them. Okay, were you guys okay with these equations?
Yep.
Okay. And these we've been working on, so they shouldn't have been so bad. So you tell me, this is your review, you tell me if you have any questions.
These are good.
And there won't be special triangles if I'm asking you to find another function. If I'm asking you to find an angle without a calculator, then it has to be a special right triangle. But if I'm just asking you to find another trig value like a sine, a cosine, a tangent, a cotangent, it can be any triangle that we want it to be. But without a calculator, I can't ask you to find an angle unless it's a special right triangle.
I think it's
Okay.
yeah. Why is it? Can you put the domain 0 pi?
It actually, what I did was I unrationalized this. If you rationalize this, that's fine. That's what you're going to have to just reduce it at the end. I just reduced it in the beginning. You know how they do 2 pi over 2?
Yeah.
It's the same thing. So I unrationalized it first. But if you do it at the end, all you have to do is reduce yours at the end.
Do we have to unrationalize and say?
Nope, you don't. But at the very end, you just have to reduce it. That's all.
Okay, so we have to reduce the
Always, your answers always have to be reduced. Reduce radicals, reduce fractions. But the one thing you don't have to do is rationalize a radical in the denominator. That you can leave in the denominator. Like, remember what we said in the beginning? Well, remember in the beginning, we said if you take your ABC and you reduce it there, your X, Y, and R, if you reduce it there, you don't have to reduce them at the end. So it's kind of the same difference here. If I unrationalize it, then it kind of makes everything reduced. All right, so something strange is going on here. All right, so let's see if I can get back to where we were.
We're on 7 and 8.
Thank you.
Well, I had a question on 6.
Yeah, I saw the question.
Okay, what's the question on 6?
You put
What's that in our view?
you put 1 over radical 5x over r, but I thought it was radical 5 over 1.
Okay, hang on, let me just get there.
You know that
Cold.
like one time so
That's what I should.
Hang on.
Yeah, mine was two.
and I was thinking, I just realized last night that mine was wrong. And I was looking at when my average was so low, but
Okay, so number 6, we're back. I don't know what happened there.
Why is, cause when you reduce the arc code, wouldn't it be radical 5 over 1, or, no, wait. How'd you get 1 over radical 5?
Yeah, I don't know.
Okay, so remember when we did radical 2 over 2? You want to do it this way? Let's do it this way. Okay, so this is x over r. Find me the missing side. What's your missing side?
Not radical 20.
That's what I know.
But you can't leave radical 20. That's your problem.
Like 2 radical 5.
2 radical 5, and then at the end it will reduce.
Oh.
That's right, you can't leave radical 20.
Right.
I said you're going to have to reduce. You have to make sure all your radicals are reduced and all your fractions are reduced. Oh, thank you. But I find it easier to, well, maybe this one wasn't as obvious because it's not the radical 2 over 2 that we're used to looking at. It's the radical 5 over 5. But it's the same kind of concept. Okay, so how about 7 and 8?
we're good.
We're good?
Yep.
Okay, those were the nice kind of looking ones. And I don't know what is going on with this board.
Your computer's not nice.
No, it's not. No, it's my smart board for some reason.
I got two. Just more.
Yes.
Remember 6?
Wait, why did you put 2 for the one side? Because wouldn't it reduce to 2? You said that radical 20 reduces to 2 radical 5.
2 radical 5.
Over
But why did you put this 2?
So what is the sign?
Because I got sine theta equals 2 radical 5 over 5.
Okay, so let's see.
But I'm just wondering how you got
2 radical.
2 over radical 5.
How did you go rationalize the radical 5?
Can we use it?
I just want to understand what you're asking me. Alright, I'm back on here. I think I'm back. Can't move down yet. Alright, so this is still a problem here. So what does this become? 5 squared is 25 minus 5 is 20. So you said 2 radical 5. Shh, guys, let's have it quiet. So the sign is y over r. Okay, so if you rationalize this guy, what would this be? If I multiplied this by radical 5 over radical 5. It'd be 2 radical 5 over 5. Wouldn't it be the same thing? That's just minus ration. Yours is rationalized, mine is not.
Can we just leave it like that?
If you gave it to me like this, absolutely. If you reduced it first, then you don't have to mess around with it. But it's the same thing. It's just that we don't have to rationalize our denominators. Oh my goodness.
Layout options.
I don't know what is going on here.
Yeah, let's watch it before.
I think it doesn't work.
Alright, hang on guys, hang on.
Maybe you should realign your smart board.
I don't know that it's my smart